Okay, back to what I was going to say. Well, we don't pay you for working on flight hardware for us. We do want you to use it to get scholarships, to get into colleges, or to get jobs. You put this on your resume and you talk about what you've done for NASA. I was just talking to your teacher about that people don't believe that you can do this. But I believe it. We've been doing it for a long time now. But you need to be able to talk about it. And so I see you all have pencils and paper there. So I want you to write down who exactly you work for. NASA is at Johnson Space Center. So we are part of the International Space Station Program Office. Do you want me to? I can actually share a whiteboard. I'm going to share a whiteboard here.
I'm going to excuse myself and go back to the class.
You bet.
I think that they can take over from here. I think that they'll be ready to go for you.
Yeah, great. Because I'm just going to give them this information, and then I want them to introduce themselves. So, okay. So, yeah, thank you so much. It actually takes great teachers that are willing to go the extra miles to run this program for us. All right, so we call let's see, I'll do text. We call who you work for is the International Space Station Program Office. Put this on your resumes, put this on your job applications. Anyone know where Johnson Space Center is?
No.
Okay, got to put this down. It's in Houston, Texas. You remember, Houston, we have a problem?
Yeah.
Yeah, so it's in Houston, Texas. So now this is who you're working for. You are part of the team. We have to sign a Space Act agreement with your school in order for you to for us to send equipment and stuff. It's just like we hired SpaceX or Lockheed or Boeing. We hired your school, actually your school district, Bucks County, to work for us. So you are a contractor. I'm a contractor. NASA mostly is built on contractor labor, and you are just like that. So use it. Will you promise me you will use it? Are you all seniors?
No.
Some of you juniors?
Yes.
Okay, well, that's what I want to find out right now. Tell me your name and what grade you are and how you got interested in manufacturing.
Okay, I'm Layla Rosati. I'm a junior. I just signed up for the program today, so I might not be on there. I was having trouble with the code, but I got interested in manufacturing through the Career Explorer program here. I got to see machines demonstrated, and I think the biggest reason I came here was because of the CNC milling machine. I took a really big interest in it, and I saw many projects being done on it, and I know that's what I want to work on later in life.
Oh my goodness, that is awesome, Layla. I totally agree with you. Those CNC machines are amazing. And I wish I had that opportunity as a high school student to do it. You know, they didn't even have those machines when I went to high school. So it's a total different shop now, and people still get that impression it's like a dirty old shop, you know, but it isn't anymore. And the programming is really important for it too. So I hope you stick with us. That would be awesome.
I will.
Okay, great. Thank you.
I'm Jay. I'm in 11th grade, and I chose interest in the shop because I didn't like for a job. I didn't want to stay behind a computer all day. So moving around and learning how to do different things, I really like that. Like using my hands. So
Can you hold on a second? I just have to answer this. Andy. Good, but I'm on a Zoom with kids. So can I call you back? Yeah. Oh, so when you signed up, there should have been a program code for the students. There was a teacher code and a program. Oh, you don't have that long one that gets you in? It starts with an N? Okay. But you, okay, so the program code that once you got into to it, yeah. Okay, well, Mike Bennett will have that for you. He just has to get it for you. So the kids will have to wait till tomorrow. Is that all right? Okay. Yeah. Yeah, I can. You bet. Okay, thank you. Bye-bye. Bye. Bye. Oh, sorry about that. That was a teacher in New Hampshire who's been in our program for quite a while, and he can't get his kids on that talent authorization. But you all did it. So, but I have so many schools that are having trouble with that. So I'm sorry, Jay. I missed why you were coming to manufacturing.
I didn't want a job sitting behind like a computer, and I like to use my hands. So the machine technology business like interested me. So because I'm like always constantly moving and like getting up and learning how to do this and learning how to do that. So it's nice.
Yeah. That's a great reason for hands-on learning, and I love that you are good with your hands. You want to keep moving and doing something with your hands. So that's perfect for CNC manufacturing. That will keep your hands really busy all the time, actually. And you're making something of value, which is really cool. All right, who do we have sitting next to you?
I'm Sarah. I'm in 11th grade, and I chose this shop because it seemed fun to just make things like different objects. Just seemed fun to do that.
So Sarah, did you know you were going to be making things for NASA?
No,
Did any of you know that?
At all.
No.
I don't think we even had the opportunity, or we didn't even know a few years ago.
Yeah, because this is your first year, so no other student has done that at Bucks County, and your teacher selected you, and that's because he sees great potential in each one of you. He selected his very best students, and that's what he told me already. So I'm not lying there, just to make you feel good. That's awesome. Thank you, Sarah, for joining us. All right, who's next to Sarah?
I'm Kevin. I'm a 10th grader, and I want to become a mechanical engineer. And I just saw like engineering like in the program, and it seemed very interesting to like make parts on the CNC machine and all that stuff.
So actually, what I tell my engineering students, because like the ones at Council Rock, they're all engineering students. I tell them they need to learn about the machines. And I tell my manufacturing students they need to learn engineering. And if you talk to the NASA manufacturing people who I work closely with, they complain all the time that the engineering drawings are not able to be made in the CNC machine. So knowing both is the best advantage of all. So you're in a good position there, Kevin, and you're only in 10th grade, which is awesome. So hopefully the 11th graders and the 10th graders can stay for several years with us doing this. All right, now we have one more person.
Yep.
And it's Justin.
Yep. Justin, I'm a 10th grader, and I joined manufacturing because it was the best gateway to aerospace engineering.
Oh, wow. So you want to be an aerospace engineer, Justin?
Yeah.
Awesome. So not only what we're going to learn today is quality assurance. So when you build a part for flight, it has to be precision manufactured, but it also has to be documented as precise as the precision manufacturing, because nothing goes up into into flight unless it is documented completely from when that material was made, what it was made from, all the way through to who inspected the final part. So that is what we're going to go over is for aerospace. If you work for SpaceX, who do you want to work for, Justin?
Boeing.
Boeing? Is
Yeah.
Boeing in the area?
Yeah.
Boeing is in the Bucks County?
Right around here.
Really? Wow, it wasn't when I lived there, but that was a long time ago. All right, so now we went over who you work for. Do you have any questions? Okay, so let's get to learning, and then hopefully we'll still have some time to watch this video about the HUNCH program on another school in New York and what they did for that. So I'm going to share my screen. Do you have a picture of the drawing in front of you?
Yeah, I printed out a copy for everyone. Everyone should have gotten it. But if
Okay. No, I'm going to share that. Hold on. I tried to get, do you see my screen? It's got so many icons, it's crazy. There's,
not, see your screen.
okay, there's cat and the deer in it. If you can, now let me see if I can find the drawing. I should have it on one of these. I don't see it right off. Oh, here it is. Do you see the drawing?
Yeah.
Yeah.
Okay, so this is a drawing of the part you're going to make, and it is identified by NASA in two different ways, and I'm going to actually see if I can make this a little bigger, but you have it in front of you. Look at the title block. You can look at yours. And so it's called a lock shaft. And it's part of a handrail. So where do you think NASA uses handrails on the International Space Station? Or why do we use handrails?
Keep your balance.
Actually, yes, very much so, to keep your balance, but not only to keep your balance, but to keep you from flying or doing the Superman thing on the space station. It's microgravity. So astronauts have to grab handrails to hold on so they don't just float away. Have any of you seen videos of that?
Yeah.
Yeah.
Yeah, so the handrails become really important, and the astronauts have wanted handrails for years. More, they have a bunch up there, but NASA, I guess, didn't have the funding to purchase more handrails, so they asked the NASA HUNCH students if they would make more handrails for the astronauts, and we've sent up about 11 of them so far, but they want more handrails because they really need to grab onto them with their hands, or sometimes they actually slip their feet under them, and the feet will hold them down to the ground. So if they're working at a glove box or something, they use their feet so their hands are free. So this is an important part in that handrail. They're blue. If we get to see the video, you'll see the handrails all over the space station. They're really nice color, but NASA identifies it by the part name, and they call this the lock shaft, and it's part of the handrail, but they also have, and this is important, a drawing number, and there it is, SDG 33117297. That is a specific number just for this part. And that you always will find on the title block. Do you call it a title block or do you have a different
Yeah.
name for it?
Yeah.
Title block.
Okay, good. On this drawing, we are concerned with what is above the word material. So above the word material is actually the raw material. And you see where it says 15-5 pH? That's that's a type of stainless steel. The SS stands for stainless steel. That's a type of stainless steel. Do you know what the H1025 stands for?
The hardness, maybe?
I didn't hear you. You gotta speak up.
It's all hardness.
It is a type of hardness. It's that material has to be heated to 1,025 degrees, and I have to pay extra money when I buy something to heat that material, which affects the hardness. So you're absolutely right. But that's the heat treatment for that material. And we like our material to be heat treated before you make the part. For flight, this is important that you get a much harder, stronger part. You heat treat it before you make the part. So this is a stainless steel, a type 15-5 pH, and it's heat treated. It has to be heat treated. The number under that information is just a suggestion on what size material you want to purchase. And we don't go by that. We go by your machines. So your teacher tells me, oh, we need a 1/2 inch. And by the way, everything NASA does is in inches. So they will tell me what kind of rectangular bar they need and the dimensions they need, not using this number under there. But this is for the raw material. And next to the word material is specifications. And above it says ASTM A564. That is also a very important category of the type of stainless steel they want. It's kind of an old category system, but when I buy material for you, which I did buy, I have to have it saying that the raw material is the 15-5 with the heat treatment, and that it has to say it's a ASTM A564. So that becomes really important. If there's an accident of some sort, they can trace that material, if it failed, back to what it was with this material and this specification, but also actually exactly what material was in it. And I've actually been at Kennedy Space Center, which launches our rockets. And a rocket blew up. It was a SpaceX rocket, and we had a student experiment on it. That's why I was there. And once that rocket blew up, every door got that tape across it that no one can enter that room, because they were going to look at the documentation behind every single part that was on the rocket, including the lockers and the experiments in the lockers, to make sure that they could find out what caused that explosion. And because of the documentation, they usually do. And I'm going to show you, you don't have this in front of you. I'm going to pull this up though, because all right, do you see something that says certificate of test?
Yes.
Yes.
Okay, so when I purchase this material, I look for what I was just telling you about. I look for the 15-5 pH. I look for the ATMS, and if the material doesn't come with this, it's called a cert. It's a certificate of conformance. It's on the test, so you might want to write this name down. You can call it a COC or a certificate of conformance or a cert. There's lots of names. This is called a a certificate of test, but it must accompany flight hardware. When you're an aerospace engineer, you will only purchase material that comes with this. And I buy my material from a place in New Jersey because he knows to look for all the information that I need on this. And there's the what's it? MSTM A564. MSTM A564. And then it says condition H1025. So this material was heat treated, and that's the specification and part of the material. So now we just have to look for, oh, there it is, 15-5. Doesn't say pH, but that's the 15-5 pH material. And you can see, I'm going to go to the next page. Oh my goodness, look, it's a lot of pages. Oh, here you can see this really clearly on this page, but it's on the other pages too. Heat number. And that's a question on the test. Sometimes the heat, you can write this down, heat number or lot number, L-O-T. Heat number or lot number is found on the certificate of conformance, because the question on test is a little tricky. It's true or false, but it says, like, is everything found on the drawing? And the answer is no. The heat number or the lot number is found on the certificate. And that is exactly, tells us, this certificate tells us exactly what materials was made, what materials and what strength of the material. It tells us a lot about the material. So this is really important. You guys are going to be the quality assurance people. You need to keep this cert with you. I have an electronic copy because the teacher or the supplier sends me this to check to make sure it has what we need. So any questions on this? Or the lot number? Lot number is real important. Okay, so let's see if I can get back to the drawing. All right, so the drawing has the material and the specification, but it does not have a lot number on it. It does have notes. And they're always very important to read the notes. And note 7 says bag and tag per NASA qualifications. And what we're going to have you do is, actually, I'll stop sharing a minute. So this isn't the lock shaft. This is a tube fixture for the handrail. But what you're going to do is you're going to make 6 parts. You're going to put them in a little bag, and your teacher already has these bags, and he already has the tags. You never write or tag the part itself, only the bag, because we need to keep that part as pristine as possible, because what we're going to do is anodize it in the end. But you're just going to take the first 6 parts you make and send them to Houston. And they'll check it. I'll actually show you what they're going to use to check it. Hold on. Let me share my screen again. So that is actually a question on the test. About checking when you're ready to send your parts into Houston, you bag it and you label it. And you have to include several documents. We just looked at one of them, which is the cert. We're going to look at the other 3. There's 4 documents that have to accompany your part when you send it to Houston. So let me, I was looking for a blank, this one. Do you see this document here?
Yes.
Okay, so this is what you're going to get back when you send in your parts. This is the document you're going to get back that's evaluating your first 6 parts. And it's to help you. If there's any suggestions on what you need to improve on, it will be on this. And the first part is about the documentation, because your part is not good for us unless you do a perfect job on your documentation, which I'm sure you will after we're done with this. But there's 4 documents that have to accompany your part. The drawing, which we just looked at, right? The form 881, it's actually called sub-assembly process sheet, but write down form 881. This question on the test. What are the 4 documents you need? This is the hardest question on the test, actually. The 4 documents you need is the drawing, form 881, which we're going to go over, form 829, which we're going to go over. Those are the 2 forms really that I work with you on. And they call it the certificate of compliance. I call it the certificate of conformance, or CERT, which has the lot number. If you don't have those 4 documents, we can't use your part, even if it's precision made. And any questions? We'll go over. We went over the drawing, not completely yet, but we went over the CERT with the lot number. That's how important what I was just showing you is so important. That's the first thing they check for. Then they check that there's no sharp edges, especially on the handrail. The astronauts are grabbing it. They don't want to get a burr or a sharp edge cut their hand. That's a question on the test too. Why can you not have sharp edges? Because you don't want to hurt the astronauts. And you'll get rated. And this is hard to do because our inspectors at Johnson Space Center are really tough. They actually go over the part with those white linen gloves, and if one of the little strands of thread get caught, they make us do it all over to do some rework. So when you send in your part, try to have no rework required. Minimum rework or complete rework is sometimes needed when the kids send in their parts, but we want to shoot for satisfied. The geometries, the radiuses and diameters, there is a question on the test about diameter. And we say diameter as a DIA. So I'm looking at your drawing here because you have a lot of diameters. I see radiuses. R is radius. And you don't use, on your drawing, it has a circle with a slash through it. But the question on the test is, what does DIA stand for? And that's diameter. So the geometries are important. All dimensions are within tolerance, and they'll check every dimension. The surface finish has to be like fine jewelry. And it takes a lot of finesse to make sure there's no sharp edges and keep it within tolerance. And you have to keep your part clean. That is one of the most important things, that there's no scratches on your part. And the last thing, the labeling, I send you the labels. Your teacher already has the labels for the bags. So you will have the label. We put that part number, that SDS or whatever it was, and actually we put the lot number on there. That's how important the lot number. Something goes wrong, we know exactly what material that was and who made it and what was in it. And then the packaging. which your teacher will package, we will send you a prepaid UPS list for that. So a label that you don't have to pay for the shipping, we'll send you a prepaid UPS label. Okay, that's kind of just a quick review of what we need to go over. I'm going to start with this one. Do you have this sheet in front of you?
Yeah, we have.
We have it.
Okay, awesome. All right, so this is called the sub-assembly process sheet. It must accompany your parts, but as we just saw, if you look at the bottom, it will say JSC Form 881. And I like to call it Form 881. So here's some questions that are on the test. You can only use black or blue ink on this form. This is a legal document, and any legal documents, only black or blue ink. You cannot use pencil, you cannot use orange or purple ink, and you cannot use a marker, a Sharpie. Only black or blue ink. Another question on the test is, do you have to put the complete date, the month, the day, and the year on this document and any of your documents? And yes, you have to put the complete date, including the year. So I'm going to put that in here for us. I like if you put it this way, put the whole year 2022, put the month, the day, and the year. And I'm going to copy that. And I'm actually going to highlight it. So remember that. That's a question on the test. Do you need the year? And I've seen the people at Johnson Space Center go through and it's a book like this, filled of documents for our parts. And she'll look at every page to make sure we have the year on it too. And if we don't, we have to go back and figure out what year it is. So the only part you fill out is this part in highlighted in yellow on this first kind of rectangles. Because you check it's the right lock shaft, the right number, check the drawing. The drawing always takes precedent. It even says the revision number, which is the first question on this form, to record the revision number, and it's on your title block. And I'm going to pull that up so you can see that. See if I minimize that and go to this drawing. Yeah, so let's see if we can, yeah, it's right here by the drawing number. If you look on your drawing, it says REV stands for revision, NC is no change. So that's the first question on our get rid of that. Get rid of that. Whoops. Not sure why that come up. I'm gonna get rid of that. I'm gonna get rid of that. Just trying to clean it up. And back to this form. All right. Do you see this form again?
Yes.
Yeah.
Yes.
Okay. So in here, you're going to put NC. Because that's came right from the drawing. And NASA always likes two people working on any of their parts or their documents. So here you're going to date it, just like with the year again, but one person's going to be the tech who actually probably is working on the part, making the part, and then one of you will be the quality control person, the QC person, and they will have a stamp that looks like this. And your teacher already has these stamps, and I think he has several of them. So the QC stamp is, instead of your signature, you're going to be assigned a stamp. You cannot share this stamp. That's a question on the test. No sharing the stamp. It's like your signature. It is your signature, because so many times we can't read initials, but your teacher will tell me who has each of the stamps. And so I'll know if you stamp it, let's say your number was 102, I'll know who it was in this particular year. If you lose your stamp, just tell your teacher to let me know and I will issue another one, but I'll take your name off of it so that if I see that again, I know it wasn't your stamp. So don't worry about losing it, but the important thing is you put it in a secure location so you don't lose it. Does that make sense?
Yes.
All right, and you already have stamps there. Your teacher has, and he will assign them to several quality control people. All right, so that's step one. Any questions on that?
No.
Step two, we actually kind of went over. I put I highlighted raw material and I put the information down. It's all copied from the drawing except the lot number. Where does that come from?
The COC.
Right, that's not in the drawing, and that's a question on the test. Is everything in step two from the drawing? And the answer is no, the lot number doesn't come from the drawing, it comes from the COC. But this was the description right above the word material on the drawing. This is the part number that was there. And I just rewrote the same thing every time. It doesn't matter. Really, the part number is just the 15-5 pH and the H1025. But I included this stainless steel. And this was this above the word specification. And this came from the cert. So then all you do is you date it. One person initials it and one person stamps it. And it doesn't have to be the same person. It should be the same person stamping it, but the initial tech who's ever working with them could change. We probably wouldn't be able to read those initials anyways. Any questions on that? Step two. Step three is just that you're machining the part per drawing, and you just check you're doing the lock shaft and with that drawing number. And so that's really easy because you would be doing it there. It's hard to make a mistake on that one. But then you would date it, initial it, one person initial it, and a different person stamp it. Number four, that one is hard because you have to make sure you get rid of all your sharp edges. And that takes a lot of finesse because you can't change the tolerance. You don't want to ruin a beautiful part trying to get rid of the sharp edges. And that has been done. So you have to be patient in making the part and be patient in inspecting and deburring the part. But after you do that, you date it, somebody initials it, and the QC person with the QC stamp stamps it. And then the step 5 says that you did the other form that I'm going to teach you right now. So we're just going to say that we did it. And we stamp it. So another question on the test is, and people get this wrong, and I think it's a really easy question, so don't get it wrong, please. You only do the first 5 steps in this Form 881. Only the first 5 steps. Because you see the 6th step says anodize. And you don't anodize it. It's a complicated process. That's why we need this part as smooth as silk, because when you anodize something, it has to be really clean and smooth, no scratches. So we actually, NASA doesn't even anodize it. It's because it involves a lot of chemicals. I visited the shop that anodizes it in Houston. So we sent it out to be anodized. But there's 10 steps here. You only do the first 5. NASA will do the last 5. Are we good with that?
Yep.
Yeah.
All right, that's one form. We just have one more form to go. and this is a very important form, believe it or not. That's a really important form, that you do it as accurately and neatly as possible. All right, so this last step says form 829, and you should have that form in front of you. It says dimensional inspection.
Yeah, we have it.
Okay, so I'm going to pull that one up. I'm only going to pull up page 1, but there's 2 pages. That's a lot of work, because now that you manufactured the part, you have to inspect each of those little dimensions that were called out on the drawing. So if I had to rewrite my test, I would ask a question. It's not on the test, but it's so important it should be. I might have to add it. That the drawing, write this down, the drawing takes precedent over any of these measurements of tolerances on the form 829. The drawing takes precedent. The drawing is the right information. This might have something different. And it does, actually. So you got to be really careful. What I want you to do is keep the drawing in front of you when you fill out this form. Does that make sense?
Yes.
Yeah.
Because the drawing is the part that has this information correctly. And this actually, it lists it. So some of them do list tolerances, but some of them don't. And when they don't, they say to use the tolerances that are on the bottom. You see the blanket tolerance thing?
Yeah.
So if your drawing doesn't have a tolerance, then and it should say plus or minus, and everything at NASA is in inches. So, and we as machinists think of it as thousandths of an inch. So this would be 100 thousandths of an inch, 20 thousandths of an inch plus or minus, or 5 thousandths of an inch. And do y'all understand tolerances?
Yeah.
Yes.
Plus or minus? Good. It's a lot of math. And I actually, that's what I was, math. I was a math teacher, a high school math teacher, and a HUNCH teacher, like your teacher. Only I did, my students actually built electronic training hardware, and it was all about wires and electronics and crimping and stripping and soldering. We didn't have any CNC machines, that's for sure. Okay, so in this first rectangle on the top, the only thing we're going to do, and you can do this on yours, for some reason, I don't know why, but I never can print on this one. I can never write on it. And I don't know why, but you can put the date and make sure you put 11/2/2022. That's the only thing you have to put here. It will have the name and the drawing number for you already. And we'll go over each of these columns. So the print zone, that's how you locate something on the drawing, C8. And usually I'll pull up the drawing again. So let me make it a little smaller. Oh, that was kind of small. But you see across the row across the top has numbers. That's like the x-axis, and the letters are like the y-axis, and it's used to locate things on your drawing. So if you wanted to locate this angle here, and it says 3x. 3x means 3 times 90 degrees. So there's 3 angles there that have to be 90 degrees that you have to measure. And it would be in, well, C, and I would probably say they're going to call it C8, because the number is more on the 8, even though the angle is actually in 7. But we'll see. Any questions on how to read that? That's like your Cartesian plane. Are any of you taking geometry now?
Yeah,
I took it last.
I took it last year.
I'm taking
Yeah. That's great, because then you're very familiar with using the X and Y axis to locate points, right?
Yes.
And that's exactly what we do in drawings. I wish when I taught geometry in high school, I wish I had, because they say, when are we ever going to use it? Well, here you do. You use it in manufacturing. How awesome is that? So, so that's the first column. I'll put this up. That's the first column, and it did say, there it is, C8, 3 measurements that have to be 90 degrees. Do you think you can put 3 measurements in this cell?
Probably not.
And look here, it's 4 measurements. So what I want you to do is, actually, you probably could fit 3, probably can't fit 4. If all of the measurements are 90 degrees, and so they're all in tolerance, you could just put one of them down. If one of them isn't in tolerance, put that one down. So if, let's say, 2 are in tolerance and 1 isn't, I want you to put the one that's not in tolerance down and highlight it in yellow. That's a question on the test. If something is not in tolerance, write it down. We're not throwing out the part yet, because maybe we can still use it, but write it down, highlight it in yellow. And the final part of this is somebody will be the quality assurance person, and they can use a QC stamp, or there's another stamp called LM for linear measurement. You can use QC or LM stamps on this form. You can't use an LM stamp on form 881, but you can use a LM stamp on this form only. But you can use a QC, that takes precedent over both of them. That's you can use a QC, you could stamp it QC or LM. But do not stamp it if any one of these parts is not in tolerance, because when you stamp this last column, it says everything is good to go. So highlight a part that's not in tolerance in yellow, and do not stamp the last column. That's a question on the test. And with this one, the 4 times diameter, what I would do is I would put, like, if you have 4 different readings, which could happen, maybe you won't, you'll have all 4 the same reading, but if you have 4 different readings, I'd put the low one that's still in tolerance and the high one that's still in tolerance. And don't worry about the other 2 as long as they're in tolerance. If one of them isn't in tolerance, then put that one down and highlight it in yellow. Am I being clear on that? I'm not sure. Are you all right with that? Okay. And you know how to add or subtract the right amount of tolerance? Because that's a question on the test. To read a caliper, do you know how to read a caliper?
Yes.
Yes.
and to figure out its tolerance, plus or minus?
Yep.
Okay,
Yeah, we get given calipers.
yeah, good. And you'll have different gauges because here we have radius gauges. And if you need any special gauges, just tell us. If you need new calipers, just tell us. Anything that you need, it has to be in really good shape because we're measuring thousandths of an inch here, you know? So make sure your equipment stays in a safe spot. And if you need new stuff, just let us know, you know, if something falls or breaks. So this form is really for 6 different parts. Part 1, 2, 3, 4, 5, 6. And that's the first that I want you to send your first 6 parts to us. So under part 1 will be all the measurements you have for part 1. Under part 2 is all the measurements for part 2. Does that make sense?
Yep.
Yeah.
Okay, so if one of these measurements is not in tolerance, you could still send us the part. Sometimes we can still use it. And if not, we probably could use it for training hardware because I don't have a lock shaft. I would love to have one of your lock shafts if it's not in tolerance. They don't give me good parts. They give me the ones that are no good. So, and quite honestly, you're the only school I've ever had making this lock shaft. So, don't throw away your bad parts. I'm coming and I would love to have some bad parts of the lock shaft from you, but don't aim for bad parts. And this column over here, which says tool, I just want you to put how you calibrate your caliper. So if you use a 1, 2, 3 block, is that what you usually use?
We use the digital caliper, so it just automatically comes up.
Oh, okay, so whatever way you have to make sure your caliper is working, just write that down, and you can just put a line through it if it's all the same. But that's what this column is for, just to let us know what you're using. And this is for either an LM or a QC stamp, but only stamp it if everything is correct. So one thing I have to stress, because this is so picayune, you really have to be precise in your measurements, is when you are making a part and you can measure something on the machine without moving that part, because every time you move the part, something could go off. But if you can measure something as you're making it, measure it, make sure it's right before you take that part off the machine. And if you have to flip your part, once it's off the machine, check your part again. Keep checking your measurements. That's my advice. It's not a question on the test, but just keep checking your measurements. The quality assurance person is your best friend, even though you might think it's your enemy, because they're always at you checking your part, but they are the best friend. And actually, I've had several students who have been quality assurance people for this HUNCH program, and they've gotten jobs right away as quality assurance people. So it's still working with your hands like you like, but it's you're at everybody's not exactly their friend, because they don't want to hear that something's off measurement, but things are off measurement, especially when you're making a lot. So really, you should thank the quality assurance person. All right. Any questions?
No.
All right, so now I'm gonna share my screen again. I'm gonna call up the test. So you have to get 100 on this test. And the first question is about, do you see the test?
Yes.
Okay. So the first question is about this little tiny nut. We're measuring the nut, and I didn't go over how to read that caliper. And I'm not sure you have calipers that look like that. Do you have calipers that look like that?
We do.
So, that's the first question. I just want to make sure I've gone over everything. So keep the LM stamp and the QC stamp in secure locations. Okay, so I think I've gone over everything on this test. And we're going to grade it right away. But ask questions if you have any question about it. Tell me when you're done. There's no rush. But just let me know.
We're all finished.
Oh, awesome. I can't even send an email out before you're done. Okay. So we're going to go over it. You want somebody read what it says, accurate linear measurement? Do I have a volunteer there?
I'll read it.
Thank you.
Accurate linear measurement of flight hardware is vital to ensuring that quality products are fabricated to specifications and to ensure a safe manned space flight program. Without inspections on the material's length, we cannot guarantee that the fabrication was actually done to the required standards. Knowing the tolerance and understanding how to apply these tolerances make sure that the hardware will be able to handle the desired loads and meet the form, fit, and function requirements.
Yeah, and actually, the handrails that are up there on the space station, they're wearing. That's another reason we're replacing them. The handrails, you would think they're made out of stainless steel and aluminum that they wouldn't wear, but they're over 20 years old. and they are wearing, so that they need to make sure that these handrails, at least that you're making, could last another 20 years. Though the space station isn't going to last another 20 years. It's almost at its end of life. It's only maybe 5 more years, and then private industry. And probably you all will have jobs. If it's in the aerospace industry, it will be private industry building space stations in low Earth orbit. And NASA will be building space stations to go to the moon and Mars and beyond. And then once we have that established for 20 years, let's say, then private industry will be building those space stations for the moon and Mars. Right now, I do want to tell you that right now we are at the Artemis mission. Have any of you heard the Artemis mission? But the Artemis mission is our going back to the moon, and it's happening this month, hopefully. Our Artemis 1, which is a space launch system, which tried to launch, I think, back in October 2 times, but they had a hydrogen leak. But hopefully they fixed that, and the space launch system will actually go around 60 miles above the moon's surface. Artemis 2 will follow with astronauts in the Orion capsule. And Artemis 3, we will actually go to the moon and colonize it. And you all will be part of that, especially if you stay in manufacturing. Everything has to be made by hand for this space exploration. Sorry, that's a little side note. All right, let's go. So why don't each of you take a turn? Why don't we start with Justin? Justin, you read question 1 and 2 for me. And the answer.
Okay. What measurement is the above caliper depicting? Please write measurement to thousandths of an inch. I got 0.313.
Okay, perfect. And number 2.
The tolerance for this measurement is plus or minus 5 thousandths of an inch. What is the lower and upper size limit for this measurement? I got plus 0.318 and minus 0.308.
Perfect. Everybody get that? Because I didn't really go over it.
Yeah.
Okay, good. All right, now here starts, and look, it's right on the form. That's a test-taking skill. Look at the information on the form. I'm telling you, form 881, sub-assembly process sheet. True or false? Like I'm giving you that information. So is it Kevin?
Yeah.
Kevin, you want to read questions 3, 4, 5, 6, 7?
Yeah. You need to fill out all steps on the 881 form. I said false.
And why is it false?
You only have to do the first 5.
Right, good job.
And then only the month and day need to be written on the form. I said false for that because you need the year.
You
and
need the year. Go ahead.
Sharp edges are allowed on the part that you fabricate. I said false.
Why can't we have sharp edges?
Because if they're holding on to like the handrail, they don't want like to get like scraped on their hand.
Yeah, good.
The lot or the heat number is found on the drawing. I said false. The lot is found on the COC.
Right. Good job.
People can share their QC stamp with others. I said false.
Why not?
You have your own one, and if you share it, it's going to be like someone else's stamping.
Yeah, it's like your signature. All right, Sarah, this is the hardest question on the test.
What are the 4 documents that must be included in the shipment of the items? I said Form 881, Form 829, the drawing, and certification of conformance.
Awesome. That is the hardest question. Did everyone get that right?
Yes.
Yeah.
Okay, good. All right. So, Jay, you do from 9 to 11, and we'll let Layla do from 12 to 14.
Each part should be placed in an individual bag with the proper label on the bag. I said that's true.
Mhm.
10, keep the LM stamps in a secure location. I said true as well. 11, if you cannot find the LM stamp assigned to you, it's okay to use somebody else's stamp. I said false.
Right, it's your signature. You don't lend it out. Great, thank you. And Layla, you're doing 12 to 14.
Okay, so number 12, the diet DIA in the print dimensions column stands for diameter. I said true.
Perfect.
Number 13, all forms must be filled out with black or blue pen. That is also true.
Yep.
And then the last one, number 14, if a measurement is not within tolerance, highlight it in yellow and do not stamp the row with this measurement on it. I said true.
Awesome. So put 100 on all your tests, I hope. When I come, I will collect them. And congratulations to you all. So your teacher will actually, I'm not sure how many stamps I sent him, but he has some stamps, and he will assign who wants. Anybody want to be the mean guy and be the quality assurance person? Awesome. Awesome. So if he doesn't have 3 stamps, let me know and I'll make sure he gets 3. I know he has at least 2. I was running out of stamps, but I'll bring some stamps with me too when I visit. That is so cool because that's a very important part of the job. All right. So any questions? You need to brag about this. Not everyone gets 100 on that test. So you should be very proud of yourself. It was easy when you listen, right?
Yeah.
So that's why your teacher selected you. All right. Would you like to watch a really cool video about what you just signed up for?
Yes.
Sure.
Yes.
Okay. Hold on. Let me see if I can get it. It's 20 minutes. It says I can't. It's 20 minutes. And let's see if we can go to our hold on. So I want to go to our desktop. It's on our desktop. Susan. I'm going to stop recording actually. Well, maybe, yeah, I'm going to stop recording.